is Ranan. I am working for a company called Splunk. And my role within Splunk is the big data product marketing person. I came into Splunk via about a year or so with Cloudera. I was a sales engineer at Cloudera doing Hadoop. And before that, I worked many years at Oracle. So that's my background.
And my name is Maciej Jagiłowicz. I came from Poland, from Allegro Group. I work there as a monitoring specialist, senior specialist. And I was invited here by Rana to show you, to tell you how Allegro is using Splunk and Hadoop in our environment.
Okay, excellent. So what we're going to do today, we're going to cover a few things. We're going to cover, first of all, we're going to start with what is Splunk, kind of as a high level. What is machine data, kind of a Splunk terminology. Then we'll go into the first use case, and we're just going to talk about their use of Splunk as far as the use case of Splunk at Allegro. We'll jump from there to a little bit more of a technical discussion of Splunk, kind of a little bit on the technical side. And then we'll finish the session with Allegro, but the Hadoop use case. And our goal is to introduce the difference between what is a good Hadoop use case, what is a good Splunk use case, what is a good combination of those two environments, and so on and so forth. And so I'm going to introduce Splunk. So Splunk, it's a public company currently. We have about 700 employees. We went public in April of last year. We have, give or take, at this point, we have a little bit over 5,000 customers that represent pretty much anywhere from IT to security to analytics kind of customers. We got a few awards lately. So within the big data environment, we were placed as a big data innovator, as well as kind of Wikiban gave us the pure play, a pure player type of environment. We will rank number one as far as the actual company that took big data and made it actually make money out of it. So that's us.
Okay, so Allegro is a quite young company. It was formed in 1999. At first, it was a garage firm where two guys wrote a single web platform where people could buy and sell stuff. And after a couple of years, it became a group. Now it's, I think, here we have 129 platforms in 23 countries. We are an e-commerce leader in Central and Eastern Europe. On Allegro, on our main website, we have currently more than 12 million users. So the company is growing very fast, and right now we are the only e-commerce firm that is able to overstand Amazon that is trying to go into Poland, or Hbase that tried and failed. And okay, so yeah, that's part of Allegro.
When I first got introduced to Allegro, my analogy, I live in the Bay Area, and for us, it was the eBay of Eastern Europe, and I got it right away. That was my analogy, so that's kind of how I translate that right away.
Very correct.
Okay, so I'm going to start with a little bit of a background on what Splunk does. In Splunk, we deal with big data, but whenever we say big data, we are not really an image processing or video processing engine. We are machine-generated data processing. And what we do is we take that information that comes from your sensors, your email, your web logs, and we truly believe that within the big data world, that is by far the largest growing and the most prevailing part of big data. I know we're in the Hadoop Summit. In Hadoop, a lot of the discussion is around web analytics, and which means understanding the customer behavior. But from a Splunk point of view, big data reaches way beyond just the analytics side. For us, it's purely sensory data or machine data, something that just tells me, is my machine up or not? IT-based, security-based use cases, totally reaching beyond just purely the analytics. And the reason we able to process all that stuff is because we have an engine to deal with all this kind of variety and vulnerability and volume. And that's what we do well, really well, deal with machine data. When we look at what is machine data actually looks like, it actually, in this case, we have 4 examples. The very first one is someone, a user, looking at trying to make an order. The second one is a web logic application server. That is also a machine-generated data. The third one is a call, somebody that made a call, and you can see the log, and you can analyze the log. Again, that's machine data. And the last one is a tweet. Someone made a tweet. That is also a machine-generated data. So all these things can be correlated. Actually, if you look inside, you can see that in this case, what Splunk was able to do for this particular customer, the customer made an order. And we can see the customer number, and we see the order number, and we see the product number. That's the very first line. The second one, we see that the customer tried to make a purchase of that particular order, but failed. And so what Splunk can do is actually, when we look at the log, we can see that if you look at the web logic, we can see that it actually failed because the database, the JDBC connection crashed. So then the third thing on that line, again, machine-generated data, we see the customer making a phone call to that manufacturer or that website and says, I could not place the order, and he was on hold between 16:33 and 16:37. For 4 minutes he was on hold. Nobody picked up the phone, so then he got frustrated and he tweeted about it, and he basically wrote some junk stuff about them. And kind of the ability to trace that for the customer is what Splunk does extremely well. Traceability, analytics, in streams of machine-generated data. That kind of correlation is a big deal. The way we do it in Splunk is we take data that is machine-generated data from all kind of different sources, your smartphone, your clickstream, the RFIDs. We take all that data, we forward it, then we index it. And when we index it in Splunk, means that we're storing it, and we break it into small pieces. That indexing is the part that we're showing over there at Splunk indexes. And then on the right side, we see what is the outcome of that index data. We have operational intelligence on that particular set of data, which means that we can visualize that, analyze that, and kind of giving you a much richer visualization. As those click streams are coming in, as that data comes in, we can give you analytics in real time. And you're going to hear us saying the word real time multiple times. Yes. And that's what Splunk does extremely well. The use cases that we see Splunk playing in and use that, it started from an IT operation to application management and security. And then we have business analytics and web intelligence, which is a fairly counterintuitive to most people because in many cases, big data was always about analytics. That's not the case. We truly see most of the success in other areas, which has nothing to do with analytics. It's purely operational, security, somebody breached it. Breaching, I need a lot of data. It's all streams of real-time data coming in and get processed and get alerted on.
Okay, so my part of presentation will tell you how exactly we are using Splunk in our company. As I said, I am from monitoring and response team, so my team's job is to monitor real-time health of the services, servers, and applications. I will add only information that we are using Splunk from 2009, and during that time, we only expand the license that we are using, and the field that we are monitoring is also expanding. And now I will show you why we like Splunk exactly. Because it meets all the needs that our IT wants from the tool, from the monitoring tool. We have many areas that want to analyze log. We have a monitoring team where we analyze real-time situations. We have developers who wants to know if their application is, after some release, is producing more error or not. We have first-line support who is interested in knowing if, for example, Mayflow that we are sending to customers has everything all right in it. So there are many kinds of departments that are using Splunk. And the other thing that is really important for us, and it is able to do in Splunk, is that it is scalable. You can install it on a single laptop and you can install it in cloud. So that's how we are doing it right now. And in case if there are some performance issues, you can always add another piece to the structure, and the system performs well. And the last 2 points are very similar, and there one comes from the other, because as I said before, there are different departments and different kinds of people work there. So we have IT guys who are technically good. We have a business who wants to check their KPIs, if their services is performing well. And we have, for example, first-line support where people are not interested in some technical stuff, but they want the simple information if everything is okay or not. And it is possible only when the interface is easy to use. And Splunk interface is very easy. You have a simple query where simple query box where you put your query, and after a few seconds you get the results that you want to get. And that's the one point. The second thing is that all the data can be visualized in a very nice manner. We have created many dashboards, and they look very nice, and people like things that are nice. Okay, so I told you why we like Splunk, and now I will go into dig deeper and tell you where we use it exactly. In real-time monitoring, what we are monitoring right now is all kinds of web servers, logs, application servers, Hbase, for example, Active Directory, so we can check all the user accounts and so on, and security devices, some firewalls, and etc. Besides that, we have our incident management team who is interested in analyzing historical data that they can correlate with the events that occurred in the past, and take some notes from it. So it's also very easy to check the history and to see what happened. The third group is strictly for the developers when they can exactly see how the logs are, what's writing to the logs, and they can see what is happening with their application. Okay, so here we have our current Splunk architecture. On the top of this screen, we have a load balancer who is redirecting all the calls from the users to add search heads. We have currently 5 search heads. Here we have an active data center, and on the right side, left side, sorry, from our side, that's our failover data center. Now, as I said, we have 5 active sessions, and 4 of them are in cloud environment. So in case that we need another piece to add, then we have in a couple of seconds ready to deploy another node. Below, we have 2 indexers. Those are machines that are indexing data from the devices. And we have separated the one indexer for net devices, and it's in the separate network, and the other one, the major one, is collecting data from all kinds of servers, applications, and other devices. All the data is also replicated in the same time to another data center, and machines that are pushing the data, we have that are called forwarders, and we have now 1,500 at the moment. Our total data process is around 100 gigabytes. Maybe it's not a lot. Splunk have probably have bigger customers. But for now, for us, it's enough. So if we ever consider to add another devices, we should extend our license, and that's all what we have to do. Okay, as I said earlier, Splunk has really nice dashboards, and here we have an example of a dashboard from our payment system, where our monitoring guys can see in real time what is happening with communication with banking, with some transactions that are going on online, some SMS traffic, and for example, JBoss queues, JMS queues, or application error rate. So if, for example, if suddenly somebody sees that the red bars are growing, then it already means that something's going wrong, and they are notifying the specific person. Creating a dashboard like this is very simple. It takes maximum 15 to 20 minutes to build something like that, and so it's very fast to use and customize. Okay, so that's end for my
so
part.
that was the way Allegro uses Splunk, and now we're going to talk about a little bit of the technical of Splunk, and then we'll go into the next use case. And so what Splunk does, Splunk has 4 pieces, as we mentioned. We have the forwarders at the bottom that collects the data, and in this case of Allegro, we have 1,500 of those bottom that feeds the data in. Then we have the indexers, the ability to store the data and break it into small pieces. In the case of Allegro, we have 2 of those.
Yes.
And the top one, the search heads, the one that visualizes the data that we mentioned, creating a visualization in about 15 minutes. In Allegro, there was about 4 of those, if I'm not mistaken, give or take.
More.
A little bit more. And the whole thing, in their case, stores, give or take, process. The way Splunk measure kind of volume is process per day. In Splunk, we have anywhere up to our high end reaches close to 100 terabytes every single day. And anywhere from there down, it really matter of increasing the number of forwarders, indexers, and search heads to increase the capacity. And so this is what it looks like. You have, in many cases, in many organizations, we have thousands of forwarders, 1,000, 2,000, collecting the data and moving the data to the middle tier. And the middle tier is our index tier. And that's the one that, again, we can increase. In some cases, we have people with 10 indexers, maybe 20, maybe 100 indexers. They all get, the more you have horizontally scalable, the more you can process. And on the top level, the multiple users that can access the data are each have their own visualization based on access control. That's a big deal for us. Different individuals, different departments will do not see each other's data. And in Splunk, it's a big deal. So we had that visualization by the monitoring team in Allegro. They may have a different one for the sales team and a different one for marketing team. So that kind of ability to separate and secure and visualize and keep that increased capacity purely by commodity hardware is a thing we do extremely well in Splunk. In Splunk, we have an engine for real-time analytics. It is very useful for alerts. And the way we do it is actually in memory. We have a way, as you specified in the GUI, in the UI, you specify, I want real time. We will give you a window of events, never stops. It's not a search. It's a window that never stops, keeps on searching the data, visualize the data. If something goes wrong in that window, you will get an alert. And the way we do it is not by going to the disk necessarily, but immediately from the stream, you will be able to visualize the data. That's a big part for Splunk. Not only collecting, not only indexing, not only visualizing, but also giving the entire thing with alerts in real time. Kind of as a product point of view, we actually install it. It's a single product. It's not 20 different projects. This is, from an installation point of view, it's a single unit. The second part of it, it's a platform, which means it collects the data, it indexes the data, and then it analyzes the data. And the right side, proven in multi-terabyte scales per day. Like I mentioned, we do have several customers that above 10 terabytes every single day. We have all the way up to a customer or two at this point that reach the close to 100 terabytes every single day. And that range all the way from the 100 gigabytes or below all the way to hundreds of terabytes is purely mathematics. You increase that layers horizontally. Very similar to Hadoop concept, but Splunk by itself, core is C++. And so what if you do use Hadoop? How do you complement Hadoop with Splunk? What we have in Splunk is we have several connectors. We have, I wouldn't call it connector, but it's a bidirectional way of talking to external systems. From the upper right, we have the SDK, the APIs that can extend Splunk to mobile application. You can write code, so you don't have to use our user interface to expose it. The second part is that we have Splunk Hadoop Connect. It's a bidirectional with Hadoop. And on the left side, we have Splunk DB Connect, which basically allows us to enrich data from the relational database. And so the Hadoop Connect allows us to move data from Splunk to Hadoop and from Hadoop to Splunk. It's a purely bidirectional, very flexible ecosystem. DB Connect allows us to do a few things. Not just move data from a database to Splunk, that's one thing, but also do enrichment. Enrichment means the machine data that came to Splunk says 1, 2, 3, 4, 5. I have no idea what product it is. I have no idea what it is, but the database may have the description. The database may have a price of the product. That ability to enrich data is a big part of DB Connect. Enrichment, basically importing the data, as well as actually generating SQL commands from within the Splunk user interface and combine that with machine data. That ability to bring that enrichment is a big part for us. So that then you go into the website and you bought a product and the product said some number, the machine just displayed the number, but we can then do revenue, we can do kind of a description, a much bigger, richer environment with the database connected. The third one is the Splunk developer platform. Again, back to our integration. It's the ability to extend Splunk with Java, JavaScript, Python, and any APIs, including our REST APIs. To extend that, again, this is for mobile application and platforms that are extending beyond the Splunk traditional way of doing things. The next part, the last one, we in Splunk also have Splunk Hadoop Monitoring. As I mentioned, Splunk, big part of our use cases is IT-based operation, and monitoring Hadoop is just another one. It's the ability to monitor Hadoop, but also monitor the relational database, monitor the switch that Hadoop is using, monitor the disk, and all that ecosystem that may be using Uzi for some of you that knows it's an application server. You need to monitor that as well. Splunk is kind of the ecosystem that can monitor every single part of the Hadoop truly end-to-end. And with that, the next use case.
Okay. So on start, I will tell you when our adventure with Hadoop started in Allegro. I think in September 2012, one of our tech meetings, one guy stand up on the stage and said, okay, we have something like Hadoop. We are building the cluster of it right now, and there is a team of 2 or 3 guys who are creating some app for gathering web page statistics. Okay, I said, okay, we'll see how it goes. And after a half year, we can say that we have a fully functional Hadoop cluster. Maybe it's not very sophisticated right now because all we have is 2 main services, that's HDFS master and MapReduce. We have H data nodes right now separated in different racks, and some additional services like Hive, Pig, or we have Flam, and so on. And for now, it's some kind of a playground for us. We are testing what kind of data we can put to HDFS and what information would be useful for our business. So here we have some details about this cluster. And as you can see, we have 2 name nodes, one in active mode, one in standby mode. Our total capacity capacity right now is more than 100 terabytes. And as you can see, only 2.5% of it is used right now, so it's the beginning. And maybe this is interesting for you. We have about 1 million files stored in HDFS right now. So after this half of the year, we started to think what we can use Hadoop for. So the first thought that we are talking about was to use it as a big data archive, a place where we could store all the data from monitoring tools, from some other systems, where it would be available, for example, a year after the event, that, for example, auditors will come to us and say, show me the data from this period, and we say, okay, no problem, here you have it. So this is the first place where we could use Hadoop right now. The second one is, as I thought before, is the guys that are building something like Google Analytics for Allegro. Currently, they are testing it on one of our services. But I think a week ago, I was talking with a guy from this team, and he said that it's going quite well, and we are moving it to our major services. And the third option would be to use to store the data from our mail systems. Currently, we are generating about 1 terabyte of logs, mail logs during the month. So we could push this into Splunk, but for us, it's not so important data that we could use our license to store this data in Splunk. So we are figuring to push this to Hadoop. Okay, so where we won't use Hadoop for sure is not for real-time. As Ronan said before, Splunk is better in this case because we have out-of-the-box solution and it's working marvelous. The other things that are mentioned here, I'm not saying that it's not possible to use Hadoop for this task, but it requires a lot of workload from our guys and resources we have to spend to build the front end, to, for example, visualize the data, to analyze it, or to write some access control tools. So for now, we are not using it. Maybe after time, when we think that Hadoop will be a very good solution for us, maybe then some teams will want to build this front ends or this data analysis tools. But for now, we are using Splunk for it. Okay, so generally, I told you where we are today. It's a playground where we are testing what we can do with it, and where we want to go with this. Probably this tool of Google Analytics that we want to copy or build our own one will be the main tool that we're using Hadoop for. The other solution that we are thinking, especially guys from my team, is to store historical data from Zabbix, our other monitoring tool, into Hadoop, because we have quite a big installation of Zabbix, and the data that we are storing is quite big, and it would be really good to have this data put into HDFS and to store it for a couple of years to see if it's still necessary or not. Okay, that would be all from my part. Thank you for your attention. Ronan?
Yeah, so I'll finish. I have the last slide or two. Kind of from a Splunk point of view, we mentioned we have 5,200 customers. We're a public company. We just announced our earnings probably 3 weeks ago. And as you can tell from the kind of from the volume and the different kind of technology area that people are using Splunk, it's used everywhere from truly big data to just monitoring and anything in between. So it's a very versatile tool. And in the case of Allegro, kind of the ability to visualize and analyze and apply access control on top of Hadoop is something that we working really hard towards, kind of the ability to extend Hadoop as purely storage, ETL, batch processing environment to something that you can actually expose to hundreds of your end users. We have many customers that use Splunk with 100, 1,000 end users. Each one sees their own visualization. Hadoop, on the other hand, has some development and some kind of maturing to do around that area. And that capability to take that Hadoop environment and expose it to the masses is what Hadoop Connect, Splunk Hadoop Connect can definitely help on that kind of ecosystem that can bridge those two environments. Kind of in a nut, and this is my last slide. You can definitely come and visit us in the booth. We have demos of Hadoop Connect, DB Connect, a Splunk Basic, and we will be happy to show you what machine-generated data, how do we turn machine-generated data into a operational insight, kind of the visualization part. It's a product-based solution, real-time platform, big time for us, the streaming of data, and the last one is performance. And thank you, and if you have questions, please let us know. Yeah, go ahead.
Okay, we have Splunk for monitoring special area of our company, this payment systems. And we have, for example, Zabbix that is used to monitor the other less important stuff. And the data that we would like to store in HDFS is not the data in Splunk, because what we have in Splunk right now is sufficient for us. We don't need to move this data to HDFS right now. But the data in Zabbix, which are currently just stored in database, they can be moved to HDFS without any problematic solutions right now for us. And we could use this data later. So it's not something that Hadoop is gonna move Splunk to some site and said, okay, Hadoop is the major archiving tool for us now. No, it's a separate thing. Maybe we'll think about integrating Splunk with Hadoop when we would like to visualize the data in HDFS. Maybe it's better for us to buy this app and have it done out of the box than spending some time to build some tools to visualize the data.
So you're not trying to do, what you're trying to do with HDFS and Zabbix is not as complex as what you're doing with Splunk.
It's not so complex. It's the data that we want to store from Zabbix doesn't require at the moment to be visualized. We only have to put it somewhere and keep it for a long time. And data that we want to visualize all the time, for example, from the year to now, we use Splunk for it because it's ready and it's working right now.
I'm working for a non-profit organization where we solve cash constraints, but Splunk looks nice and it will solve some of our problems. So considering that, what are the licensing terms and like what kind of money would you need?
For you?
Do you have non-profit licenses and what are the terms?
So the answer is yes, we do. It's called Splunk for Good. So it's definitely geared towards exactly that area. Splunk for Good is purely kind of to help the community in all kind of different, right now, in the US we had Hurricane Sandy a while back, in New York area. Splunk was actually used to monitor what's going on from a response to all kind of, and it was 100% non-profit. From a profit point of view, the way we license Splunk is between the forwarders and the indexers, that ability to move data from the forwarder to indexers, that's how we really measure licenses. It's consumption of data per day. And up to, you can find it on our website, up to 500 megabytes per day is free. Above that, we start charging. That's one way. The other one, we have a product called Splunk Storm. Splunk Storm is Splunk as a SaaS model in Amazon. And also that has a little different of a model. It's not consumption per day, it's purely volume. And up to, I can't remember exactly the number, but up to a certain number, it's also free. So there's several ways of kind of either getting started or truly if you go kind of from the non-profit point of view, we can definitely help. Yeah, it is a cool tool. Truly, I mean, I came from Cloudera. I did Hadoop for a year plus, and writing MapReduce or Hive or Pig or any of those environments truly required someone to know what they're doing, the data scientist, the developer type, where Splunk reaches the other parts, the not necessarily people that want to or know how to write code. It's clicking on things and generating user interface without that very deep technical. And of course, allowing the deep technical guys to do some experimental data very quickly is a big part of what Splunk does. Okay? Thank you very much.
Thank you.